A small 7 kilogram rocket is being launched vertically. The thrust force is described by the function f of t equals negative 5.5 t squared plus 27t plus 544. Assume negligible air resistance, but do not forget the gravity force on the rocket. Use gravity equals 9.81 meters per second squared. What is the maximum height in meters achieved by the rocket before it falls back down to Earth? So overall, the picture for this problem is we're looking to set up a new equation for the thrust force and then use that force to find acceleration and then integrating the acceleration for velocity, setting that velocity equal to 0, then integrating the velocity for position function, and then plugging in that time that we found from setting velocity equal to 0 into the position function to find maximum height. To start, we'll define the new thrust force equation, now accounting for the gravitational force on the rocket. We'll do that by subtracting the gravitational force from the current equation. We can find the gravitational force by multiplying mass times gravity. That gives us 68.67 newtons. So we subtract that from the original equation. Next, we'll use that equation that we just defined to find the acceleration equation. We do that by dividing the equation by its mass, 7 kilograms. We integrate that acceleration equation to get the velocity equation, which gives us negative 11 over 42 t cubed plus 27 t squared over 14 plus 679 over 10 t plus c. We have to find out what our c value is using our initial condition that its initial velocity is 0, our c is 0. We set the velocity equation equal to 0 to find the time at where the rocket is max height. When we set it equal to 0, we get a time of 20.19. We find the position equation by integrating the velocity equation. From that integration, we get negative 11 over 168 t to the fourth plus 9 over 14 t cubed plus 679 over 20 t squared plus c. Again, using our initial condition that the initial position is 0, our c is 0. We can use this position equation and the time that we found from setting velocity equal to 0 to find the max height by evaluating the position function at time 20.19, which is approximately 8,250 meters.